Hello and welcome to today's ACM Tech Talk. This webcast is a part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professional and students. I'm Jan Timonovsky, ACM Education and Professional Development Manager. For those of you who may be unfamiliar with ACM or what it has to offer, here is some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. You can see some of the highlights on your screen. ACM provides access to the ACM Digital Library, the world's most comprehensive database of computing literature, leading publications and global conferences that draw top experts in a broad spectrum of computing topics, support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards, and the ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. If you have questions at any time, please type them in using Zoom's Q&A button. We'll organize the questions as Jan speaks and try to get to as many as possible. This session is being recorded and will be archived. You'll receive an email notification when it becomes available, and check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open up on your screen. Please take a minute to fill it out. It really helps us improve our Tech Talk program. So today's presentation is Software Product Management, From Opinions to Data-Driven Experimentation by Jan Bosch. Jan Bosch is a professor at Chalmers University of Technology in Gothenburg, Sweden, and director of the Software Center, a strategic partner-funded collaboration between more than 15 large European companies, including Ericsson, Volvo Cars, Volvo Trucks, Saab Defense, Scania, Siemens, and Bosch, and 5 universities focused on digitalization. Earlier, he worked as vice president of engineering process at Intuit Inc., where he also led Intuit's open innovation efforts and headed the Central Mobile Technologies team. Before Intuit, he was vice president and head of software and application technologies laboratory at Nokia Research Center, Finland. Prior to joining Nokia, he headed the software engineering research group at the University of Groningen in the Netherlands. So Jan, without further ado, take it away.
Thank you very much, Jan. I really appreciate the opportunity to present here, and I want to thank you for the opportunity that was given to me. So thank you all, and for those of you that were in or were hoping to have the webinar earlier in the year, we had to cancel the postpone the webinar at the last minute because unfortunately my father passed away a few days before this webinar was being scheduled at that time. So I don't want to spend too much time on that, but I wanted to apologize for any inconvenience I may have caused any of you that had hoped to participate at that point in time. But I'm glad that we have a chance today to go through this. And what I was hoping to talk to you about is this whole notion of software product management and the fact that a lot of the work is still based on opinions, and that I feel we need to become much more data-driven and much more experimentation-driven in our day-to-day practices. So if we look at what I was hoping to cover as part of this talk, the first is that I will go and try to convince all of you that companies, based on our research, are wasting about half or more of their R&D budgets building things that are simply not used or used so seldomly that the investment in building them is not actually worthwhile. That is caused by a situation where many companies are not clear, not sufficiently clear on what actually delivers value to customers. So they may talk a lot about value, but if you try to turn it into quantitative and measurable terms, many companies are not clear on what it is that actually delivers value to customers. And then finally, even if you know what might deliver value to customers, you should, rather than building the whole thing and making it gold-plated and throwing in a kitchen sink, what we need to do is you make much more use of experimentation to ensure that what we hypothesize might deliver value to customers actually does deliver value to customers. And with experimentation is a very much more effective way to achieve that than the traditional ways in which many of the companies that I work with are currently working. So what I was hoping to do in this presentation, I will try to leave time for questions and discussion towards the end, is to give you a quick introduction into who I am, but especially the Software Center, because that gives a little bit of a backdrop of where the research results that I'm presenting are coming from. Then I want to dive into a topic that I think everyone understands, but I still believe is worthwhile to dive into a little bit, which is the notion of digitalization. Then I want to spend some time on the state of software engineering and why I believe we are in, to be honest, a relatively poor state in terms of the effectiveness of R&D. And then I want to talk a little bit about how can we get away from the traditional opinion-driven, requirements-driven approach to much more of an outcome-driven approach, and then we'll get to conclusions. I'll try to leave something like 10 or 15 minutes towards the end for questions, as I mentioned, because I believe it would be good to interact around these questions. But you also have my email address, so if there's anything that you would like to discuss after the webinar, feel free to reach out to me. I happily engage with you in some of your specific experiences. So very briefly about me, I used to be a young and innocent professor of software engineering in Sweden and in the Netherlands. In the early 2000s, I got the opportunity to work for Nokia, as you heard in the bio that was just read by Jan. After several years at Nokia, I moved to Silicon Valley and worked for Intuit. And then in 2011, for a variety of reasons on the private side, we decided to move back to Europe, aging parents and what have you. And these days, since then, I am a professor at the Technical University, Chalmers University of Technology in Gothenburg, Sweden, as well as I have an appointment at the Technical University Eindhoven. I run Software Center. I do some board work, angel investing, and consulting. Software Center, which I've already alluded to, is a collaboration between 15 companies and 5 universities. You probably recognize quite a few of the logos on this slide. This is a purely partner-funded initiative. So the companies are actually paying for being members of the Software Center. The universities are also contributing with in-kind resources to the center. And the mission of the center is to significantly improve the digitalization capability of the European software-intensive industry. I will come back to digitalization later on, but basically we're talking about working more effectively with software, data, and artificial intelligence. One of the things that you'll notice that virtually all of these companies are embedded systems or cyber physical systems companies. So they almost all have products that have mechanical parts, electronics parts, and software parts included in them, as well as, of course, AI parts and a lot of data that gets generated from them. And that's important because different from a company like Intuit, where they used to work for, most of these companies are not a pure SaaS company, but are much more embedded systems companies, as I mentioned. We have a collaboration model which really aims to develop strategic partnerships with these companies to help them accelerate their adoption of digitalization practices. Our measure of success is a company that is in Software Center will evolve and become better at digitalization faster with us than without us. And in order to accomplish that, we organize our work on the research front in 6-month sprints. Even if the projects may run much longer, every project basically operates in a 6-month sprint, then delivers a system-level holistic perspective typically on the project. So we focus on business aspects, architecture aspects, ways of working, and organizational aspects. We organize our research in a number of themes. We have work around continuous integration and continuous delivery. We have work around architecture, technical debt management, API management, those kind of questions. We do a lot of work around metrics and have a world-leading researcher in the field of metrics leading this theme. We have a theme on customer data and ecosystems, and then the most recent theme that we started a few years ago is called AI engineering. And Software Center has been in existence since 2011, and I've been the director since I moved back from the US to Europe. We're doing quite well. I feel it's not just papers that come out of this, but actually the results that we generate are being used by companies. I will later on show the Stairway to Heaven. I don't have time to show some of the other models, but these are research results that come out of the collaboration and that are actively used by the software center companies. And we do not only work with embedded systems companies, we do work with SaaS companies as well, and we take a lot of inspiration from how these companies are actually working. So if we move to digitalization, I think the important part is to realize, especially for companies that have mechanics and electronics in their products, how the world is changing. So I drive an Audi A4, and I'm assuming that many of you have a car of some kind. But basically, whenever I bought a car, that car was the best it would ever be the day I got it from the dealer. And from that day on, it would get a little bit worse every day until I was so sick and tired of the old clunker that I would trade it in and I would buy my next car. And my next car would be a little bit better than the previous one when I got it. But it would still be the best it would be the day I got it from the dealer, and it would get worse a little bit every day as I would use it. The world that we're moving towards is what we can see on the top right of the screen, which basically says the day the customer gets the product, it is the best that we as a product delivery organization can provide it, can build it at this point in time, but it will also be the worst that it will be throughout the remainder of its economic life. And from that day that the customer gets access to the product, it will get better every day the customer uses it. And how does it get better? Well, we of course have DevOps and software deployment. We have upgrading of AI models as part of the software deployment. We can periodically upgrade electronics. There's a discussion in the automotive industry, for instance, to have cars that come out of a leasing contract after 2 or 3 years and that go on the private market to give them at that point an upgrade to the electronics. And maybe we have to occasionally replace the mechanics. But the basic user experience is every day I get the product, I use the product, it gets a little bit better than what it was yesterday. And I think that that's the essence of digitalization. And as you reflect on this, and I'm sure that many of you have been in the industry for quite some time, if you reflect on how we deliver value to customers, we can actually see a continuous shortening of value delivery cycles. We started off with product generations. If you talk to Volvo Trucks, one of the companies in the software center, they basically have platform generations of 7 years. And every 7 years, there is the next generation of the platform. And that's when you have the major upgrades to the value delivered to customers in terms of fuel efficiency and effectiveness and driver comfort and all kinds of other aspects of a truck. Of course, in the software industry, we already in the 80s and 90s moved towards annual software updates. So every year there was a new update that was provided, and you would have to go through a few weeks of hassle as you were going through all the software updates and the integrations that stopped working. But then you basically had, again, a stable system for, I don't know, maybe 50 or 45 weeks of the remainder of the year. Now, many companies, including companies in the embedded system space, have moved or are in the process of moving towards DevOps or DataOps or AI or MLOps. I mean, for those of you that know Ericsson, one of the largest, actually the largest telecommunications company in the world, they for years now basically provide new software to live base stations for any customer that wants it every 2 to 4 weeks, depending on the product. So this is something that is a reality in many companies. But we're also seeing that A/B testing, which is an even faster way of delivering value to customers, is becoming prevalent and more adopted in the embedded system space as well. Of course, it has always been, for a long time, been extremely well used in the software as a service world, but we now also see it coming to other industries where the idea is that you deploy the A alternative and the B alternative in your fleet of vehicles or in your fleet of products. You measure which of the two is doing better, and then within a few hours or a few days, you can actually decide to give everyone A or everyone B because it simply performs better. And then finally, we believe that reinforcement learning, one of the things I will mention a little bit later on in the talk, is a mechanism where systems fully autonomously can experiment with their own behavior in order to deliver more value to customers. And that is an even faster way of delivering value to customers. As we see companies evolve, and I have references to articles in which we have published this in case you're interested, the slides will be available afterwards. But as we evolve, many of the companies that in the embedded systems world started off as mechanical engineering companies, then added electronics, then added software, then added data-driven practices, and of course, most recently, artificial intelligence. And this has a number of implications. The first is that although we still need mechanics and electronics, more and more of the commodity functionality lives in those boxes, and more of the differentiation sits in the software, data, and artificial intelligence. Once the innovation moves from atoms to bits, we often see a shift in business models. And we see that also in the embedded systems world, where if the primary value delivered in a product is coming through mechanics and electronics, so atoms, we see that the business models tend to be transactional. You buy the product, you use the product, and then you replace the product with the next generation. But when the primary value delivery is through software, data, and artificial intelligence, we see that many companies move to some form of subscription-based or continuous revenue model in order to make that happen. The other thing is that every time there is a new technology added, we need to evolve the business ecosystem and technology ecosystem in which we operate in order to add new partners to this. And then finally, of course, this comes with new ways of working. I already mentioned DevOps, DataOps, and MLOps. And every time we have a new technology, we have to add new ways of working with that technology to our systems. We did a rather elaborate model based on several of the companies in Software Center and some outside it, where we try to outline along 4 dimensions how companies transition from being traditional companies to being digital companies. And we have the 4 dimensions: the business model, product upgrade, data, and AI and machine learning dimension. I won't talk through this in great detail, but what we see is that companies move from selling traditional products. So I sell you a car or a product or a mobile phone, and I don't talk to you again after that. In the next step, we see that companies start to offer their product as a service. Many car companies, including Volvo Cars here in Gothenburg, offer a model where you can get a car as a subscription. You basically pay a monthly fee, and when you're done with your car, you cancel your subscription and they pick up the car and you're done with it. Once you reach that stage, often the third step is to move towards complementary services around products. So many logistics companies or truck companies, they offer trailer services or tire services or fueling services or safe driver resting place services, and all kinds of other types of services around the product itself in order to generate more continuous revenue. And then in step 4, things become really interesting. That's when you stop paying or getting paid for the product itself, but rather you change your business model to align with the customer KPIs. So in the case of a truck, for instance, this would be, I get paid every time someone or customer makes an on-time delivery with one of my vehicles. I get paid a certain sum for that delivery rather than getting paid for the truck itself. And that's when we really start to see the transition towards continuous revenue models. So again, there's a lot more in this slide, but in the interest of time, I will not deep dive on this. I already mentioned the stairway to heaven, which is one of the models that we see how companies evolve over time. So many of you have seen this. This model was defined in 2012, so that more than a decade ago. But I'm sure that all of you have seen companies move from traditional development to adopting agile practices, then moving towards continuous integration, where within the company you want to be always at production quality. Then you move towards continuous deployment, where you get the software out every 2 to 4 weeks. And what you see is that every time you take the next step, you will have to involve more functions in the company in order to make that happen. And then the stage that many companies are now trying to move towards, or in the process of moving towards, is where you start to use your R&D as an innovation system, where you use experimental techniques to actually test things out with your customer base as a mechanism to determine that you are actually delivering value, and you stop building a whole bunch of stuff that is not adding value, but rather you take much more of an experimental approach. And we're going to come back to that later on in the presentation. One of the big transitions I spent, I think, since mid-90s, I've been working on software platforms, object-oriented frameworks, software platforms, superset platforms, etc. So if people are interested in that, I happily engage in a discussion on that one. But what we see is that companies that traditionally were product-centric The moment you move towards DevOps, you are almost always required to move to what I refer to as a superset platform approach, or a Michelangelo approach, where the idea is that the superset of all functionality for all products in your product portfolio sits in a single code base. You have automated product derivation for every product that you are actively supporting and is on the market. And every time any team checks in new code into the single code base, you basically derive the next version of the software for every one of the products. And you take every one of the products through the continuous integration environment, and you make sure that you're always at production quality. Of course, there are defects that come out. Of course, there's architecture refactoring that comes in. So what we see is that the teams that you see there in the middle are basically dividing their time between building new features, so new functionality to be added to one or all of the products, architecture refactorings, and a defect backlog. And again, there's a lot more depth here, but that's not the purpose of this talk. I just wanted to mention that the transition from being a project or product-centric company to becoming much more of a platform-centric company becomes a necessity when you adopt DevOps, DataOps, and MLOps. You have no way to get around it in my experience. That was digitalization, which I wanted to set as a little bit of a context. Now, the next step that I wanted to talk about is one of the big questions in software engineering. Many of the software engineers that I work with are in the situation where they believe that if I get a requirement specification from either product management or from the customer, I build what it says in the requirement specification, I deliver the tested software that actually implements what it says in the requirement specification, then I should have developed value for customers. But how do we actually know that? How do we know that we have actually delivered value to customers? That is a big question. And many of you that have been around for a few times maybe have seen this graph, which was published in 2002 by Standish Group, where they basically show that for a typical product, a typical system, we see that somewhere between half and 2/3 of all the functions and features in that system are never used or used so seldomly that they should not have been built in the first place. The return on the investment, the R&D investment, is simply not there. It is not worthwhile to actually build those features. We found it difficult to believe that this was the case. This was also a quite old study. So about a decade ago, we ran a study with a company in the Gothenburg region that wanted to stay anonymous after they saw the results. And to be honest, we see exactly the same pattern. You can see here on the x-axis a whole bunch of services that the system that we looked at is actually has implemented. And then there are service starts, which is the number of times that feature gets actually used. And what we see is that some features are used all the time, some features are used occasionally, and many features are never used. And I have to make an important side note here. These are features that were intended to be used. Yeah, my car has an airbag feature, and I hope that the airbag feature in my car never gets activated, because it would mean that I would be in a pretty bad accident. But these features that you see on this list are features where some product manager stood hopping up and down in front of a prioritization meeting claiming that unless we get this built, we're all going to go to hell in a handbasket. And the interesting thing is that these features then get built. And then if you start to look, which many companies don't do, but if you then start to look at what is the usage of this feature and how frequently is this being used because this product manager really believed in it, then we very often see, at least half of the time, that the feature simply is not used or used extremely seldomly. So what I typically claim is that for new features in existing products, roughly the success rate is 50% or less. So that is, I think, the first thing to be aware of in the state of software engineering, as far as I can determine it based on our research. About a decade ago, I published a paper in which I introduced a notion of the 3-layer product model. The 3-layer product model is an extremely simple model. I'm not a very smart person, so I can only do simple models, which basically means that you can organize the functionality in a product, in a product portfolio, in a platform into 3 layers. there is a layer of commodity functionality that you need for your system to work, but no customer is actually going to pick your product or your offering because of the commodity functionality. It's basically table stakes. It needs to be there, but you don't actually differentiate in that way. So there you want to optimize for minimal total cost of ownership. On top of that sits a layer of differentiating functionality. That's the reason that your customers pick you over competitors. You can do things that others cannot. And here you want to focus your R&D efforts on optimizing customer value. Often this means adding variants, deeply understanding the way customers are using this, etc., etc. And then on top of that sits an innovation and experimentation layer. And there you don't want to optimize for maximum customer value or a minimal total cost of ownership. Here you want to optimize for running as many experiments as possible in order to figure out what are the things that actually add value to customers. And what you can see, of course, is that say 1 out of 10 things in the top layer is successful, you then move into a situation where you want to productize that successful innovation that you have identified. It becomes then part of the differentiating functionality layer, and you start to optimize it for customer value. And then over time, depending on the industry, this can be a few weeks, a few months, or a few years, these things start to commoditize. Either competitors have caught up with you or customers get a little bit bored with the functionality, and then it turns into commodity. And I think we've all recognized and seen that particular pattern in industry. I have now asked well over 50 companies what percentage of their R&D budget goes to commodity functionality and what percentage of their R&D budget goes to differentiating, innovative, and experimental functionality. And the best answer that I have been able to establish based on the companies that I've worked with and that I've interviewed for this is that somewhere between 70 and 90% of all R&D resources are spent on commodity functionality, and only a small fraction of the R&D budget is actually spent on differentiating, innovative, and experimental functionality. So basically innovation and differentiation. And of course, that is a big problem. There are ways out of this because many companies believe that that's just how it is. But there are very effective ways to actually reduce your investment in commodity if you partner well between product management and R&D. In one company that I'm not allowed to mention, we basically took the architecture of a platform, and we forced the architects, or we worked with the architects and product management to classify every component in that architecture as either being differentiating or commodity. And then we agreed with product management to not accept any new feature request that touched any component that was classified as commodity. Now, that led, of course, to a significant commotion in the company, but our initial assessment of the impact was that that company would be able to reduce their investment in commodity functionality from 80% to 40%. So these are the kinds of techniques that we've been working on with companies in order to make this better and more relevant. So if you ask me what, in my understanding, is the current state of R&D, it means that 7 to 9 out of every 10 people in R&D work on things that actually no customer really cares about. It's commodity, we've built it before, it should just work, and we should not spend that much resources on it. The 1 or 2 or 3 that build new functionality get it wrong half the time. So we see that a lot of features get built completely top to bottom, all the exceptional use cases, all the corner case, everything gets built, and then we find out that no one wants that feature. And if you then start to look at what is the cost and value gain that is for a company that this causes to be, what is the effect of this is basically if you have a company that spends 5% of its revenue on R&D, so how much revenue should every dollar in R&D then actually create? And the answer is 20x. So every euro or every dollar that goes into R&D in a company that has a budget, an R&D budget of 5%, should create 20 euros or $20 of business value for the company. Otherwise, things do not go together. And if you then realize that the vast majority of people are working on commodity functionality and that we are actually building a lot of functionality that doesn't deliver the value that we hoped it would do, I believe that the effectiveness of R&D today is actually atrocious. It's incredibly bad. And we're working very, very hard with the software center companies as well as with others to actually do something about this. One of the challenges, and now I'm going to go out on a limb, is actually, I think that there are some things inherent in the agile paradigm that are causing some of these problems and difficulties. And one of the things that we've been looking into, and I have a link to my blog post at the bottom of the screen in case you're interested in taking a look. I believe that agile, being defined in 2001, I think, was when the manifesto was published, is actually part of the problem here, because it is very much focused on individuals and interactions. So basically verbal requirements. It is very much focused on working software, but not necessarily tracked in real time. It's very much focused on customer collaboration, which means a lot of meetings. And it's a very reactive paradigm because it's a lot about responding to change. Now, I know that I will get a million questions around this because many people love agile, and I'm sure there are quite a few people in this call that are earning their living by being agile coaches or otherwise. But I believe that there are some inherent challenges to the paradigm, which are in part causing some of the challenges around software engineering and R&D that I've been raising. And I believe that we need to move to a next paradigm, which is much more focused around architecture and decoupling teams, which is much more focused on tracking operational software in real time. That's why we have all this data, is much more concerned with predicting stakeholder needs rather than asking the customer what they want you to build for them. And it's much more, and this is of course part of the focus of this talk, focused on hypotheses and experimentation rather than responding to whatever the customer tells that they want to have change. And so I believe that when we look at this from a product management perspective or from an R&D perspective, we need to shift from a focus on the how are we going to build this functionality, to including what functionality are we going to build and why should we build this functionality in the first place? What is the value that this actually delivers to customers? And to be honest, I still see many product managers and R&D struggle with that specific question. From a focus on efficiency, yeah, many people talk about flow and throughput, but I mean, building hundreds of features that no one uses is the epitome of efficiency, but it is very, very low effectiveness. And I think that there's a real problem there for many companies. Many companies, every company I work with talks about value, but they don't have effective ways of measuring value. SaaS companies tend to be very much better at this. I did some work with Booking.com a number of years ago, earlier part of Priceline, which I know is called Booking Group. And they have a very clear definition of value, which is basically conversion on their website. But many companies basically talk about customer value, but don't measure it. And then instead of reacting to change, proactively engage with market, customer, and ecosystems that I believe important. And then not just listening to what customers say to what they do or say what they want, but measuring what customers actually do. That is, I think, one of the big changes that we have to start to focus on when it comes to software engineering and product management. The final part where I want to talk about is I've now raised what is happening in the world. I've talked about what I believe are some of the key problems in software engineering. And I want to talk a little bit about how one could start to engage on resolving some of those issues. And the starting point for us is, and we see that the most mature companies that we've worked with are actually doing this, is to develop a hierarchical value model where I have quantitatively measured clear connections between the top level business level value factors that tend to be slow moving, customer satisfaction, revenue, profit margins, net promoter score, those kind of things, the things that you typically see in the business presentations during shareholder meetings and others, all the way down to team level and feature level value factors with connections in between at the product and system level. Yeah, and what we've seen is that some of the companies that we've worked with, often in the SaaS space, are very mature at this and are able to maintain a value model like this. But it is very difficult. And if you, to accomplish, especially in a company that is not used to working in this fashion, What we often see is that there are business level factors that are identified and shared by the C-suite and senior leadership. Many teams track KPIs or measurable factors for the functionality that they're building, and sometimes also after they have been building functionality. But the connection between the business level and the team and feature level often tends to be lacking. And what you then get is a lot of storytelling about why, for instance, feature usage frequency is positive for customer satisfaction or revenue or one of the other things, but there is no quantitative relationship between the two, and that's what we're looking for. How hard this can be, I will briefly show in this slide. This is with a car company here in Europe, where we were able to sit down with the team that built the adaptive cruise control system for the car models that this company has out in the market. They have spent a significant amount of R&D budget on this. I think millions of dollars. And we asked the team to define in quantitative terms what would constitute a successful adaptive cruise control system. And what we noticed, we had a team of, I think, 14 or 15 people in the room, is that there were many factors that were being brought up, but that there was no alignment around what the value factors were that constituted a successful adaptive cruise control system within the team. And if you then get, and you can see some of the things here, sorry, my handwriting isn't very good, but maybe you can see it on the screen, but there were some metrics like, well, it's the percentage of total time that it is used. Other people felt that it was when you deactivate the adaptive cruise control system when following a car, that is a negative factor, so we should measure that. Things like daily active users, deactivation while accelerating. There are some people that really get annoyed with the adaptive cruise control system, that when the car in front of them goes back to the right, their car accelerates really slow. And what we noticed is that there was no alignment within that team. And if you have different people building functionality based on different prioritizations of what they believe is important for the customer, you obviously get mismatches and inconsistencies in that system. And actually, the most beautiful example that I saw at one company is that we had two teams. One team was focused on improving the security of the system, and many of you are probably dealing with cybersecurity issues right now. Another team was focused on improving the performance of the system. And what we noticed was two very hard-working teams, where the performance team was trying to create all kinds of shortcuts to make things go faster. The security team was finding all kinds of security holes that they were fixing. So two teams that were working very hard. But in practice, nothing actually moved. So we had two hardworking teams that were still getting paid full time, but the system as a whole was not improving because these teams were undoing each other's efforts, which was, of course, extremely counterproductive. One of the mechanisms that we have been working on, and I will speed up a little bit to leave some time for questions, is the HYPEX model. What we here basically suggest is that you have a feature backlog that comes out of your business strategy and strategic product goals. You pick a feature from the backlog. The first thing that you do between product management and R&D is you try to define what the quantitatively measurable impact of this feature is going to be on the customer behavior or on the system behavior. So you get to the expected behavior. If we build this feature, what do we expect to see in terms of measurable outcomes? Then we built the minimal viable feature. I have understood that that's now a little bit of a non-term in the startup community. It's now called the minimal lovable feature. But in any case, you try to build the thinnest slice, the first 10-15% of that feature, in order that you believe will deliver most value to the customer. You get it deployed. That's why you need DevOps. And then you can start to measure the actual behavior. What is actually happening to the product now that I've added this minimal viable and minimal lovable feature to the system? And then what you typically see is that you will see a gap between what you expected to see and what you're actually seeing. And then there are four possible outcomes. I mean, the first may be you've built 30% of the feature and you got exactly what you wanted, and then you can basically move on to the next feature. There's no need to build the remaining part of the feature because you've already accomplished what you were looking for. Another very likely outcome is that you measure what is the impact of the feature and you see absolutely nothing. There's nothing there. There is no impact of this feature in the system. And what you should then do is you should remove the code associated with the feature from the system. You should abandon the feature and you should basically tell yourself and others that this clearly was not worthwhile. A third alternative is that you see some movement, but not as much as you would like to see. So what you do is you keep adding another slice of functionality to that feature and keep deploying it. And you keep doing that as long as the value delivery is going up. And once it plateaus, you actually stop. And then the fourth alternative, which we've seen in a few cases, is where you see some movement in the data, but when you start to qualitatively investigate what's going on, you realize that customers want the feature, but not in the way that you actually realized it. And then you should focus on implementing an alternative for the way that you built the feature in the first place, but try to figure out another way of building it so that customers actually do get the value out of it. And this is very much an experimental way of working. I think many of you know A/B testing. This is one of the things that we did with one of our industrial one of our PhD students who spent some time at a large US software-intensive company, which I'm sure you can guess which one that might have been. And here it was A/B testing that was being evaluated. You can read more about it in the paper that is referenced there. And I think many of you have done A/B tests or ABN tests, where the idea basically is that you have a very clear experiment goal, you define what you want and expect to see, and then you run the experiments. And normally in the live audience, I ask people to guess which of these is the better alternative. But in this case, the results turned out to be that treatment B decreased engagement with the stripe below the Xbox games. But the purchases stayed the same, whereas treatment C increased engagement with the stripe as well as increased the purchases made. And obviously, in this case, C was the preferred approach. So that's A/B testing. So we had the Hypex model, we had A/B testing. In general, I do want to spend a few minutes on artificial intelligence. We view software development as consisting of 3 types of different ways of developing software. For most companies, the traditional requirements-driven development will not go away. You need it because of regulatory features. You need it because of competitive parity features. You know exactly what to build. You just have to build it. Sometimes you need to lift a commodity feature into a new product because customers basically insist on having it. So there you have a simple, here's the requirement, build the functionality, test it and deploy. The second type is what we've been talking about so far. This is where we have an outcome or data-driven development. I have a value hypothesis. Yeah, I believe that there is something that will improve from a value delivery perspective. And then you take a more experimental approach where you try to implement the functionality in an iterative fashion while measuring the impact. But there is a third type, which is, of course, AI-driven development, which many of us are working with these days. Where you basically focus on minimizing prediction model errors and focus on finding machine learning models that have the best possible performance. One of the things that is important to realize is that most systems combine all 3 types of developments. All these systems are subject to continuous deployment, including the machine learning models. And typically, you want to collect behavioral data from all the components as well as from the system as a whole. And in this context, machine learning comes in as well. We wrote, and for those of you that are interested in this, published a research agenda a few years ago around AI engineering, which is all the engineering efforts that need to take place in order to successfully deploy a machine learning or deep learning model. Many companies that we work with have difficulty going from the more experimentation and prototyping phase to actual deployment in real products because they have not taken the engineering aspect into account. And again, in the interest of time, I don't want to focus on this, but there is one box in here which we at that point identified, which is automated experimentation. And that's one of the things that we've been spending time on, together with a Swedish telecommunications company, which you may guess which one it was. we basically built a system where we could fully automatically experiment with a subset of the parameters in a radio base station in order to optimize the performance of real-world mobile phones in a network. We used a multi-armed bandit for this approach, and what we were basically optimizing for is we wanted to optimize the amount of transmission power that the radio base station was using, as well as the cell range. And we found a set of settings that basically allowed us to optimize on those two factors. And again, there is a reference to the paper if you're interested and want to learn more. Another area which we have been looking into is federated learning. As well as reinforcement learning, which is also one of those places where you can have a wide variety of systems out in the field that are all training their own version of the model, and there is exchange between the different models, between the different systems, and then you get a kind of federated approach to your learning systems, and you can apply this in machine learning. But the one thing, and again, you can look at this is where we built a system which does a steering wheel angle prediction, which is an important use case in some automotive contexts that you can look at. And we have an asynchronous federated learning algorithm, in case you're interested, that performs much better in many aspects than some of the existing algorithms. The one that I wanted to talk a little bit more about, and then we're going to close this up and move towards the questions. Together with a Swedish telecommunications company, we looked into flying base stations. So basically drones that have base station functionality in them. The idea basically is that in a crisis situation where a certain area of a city is, for whatever reason, devastated, it also means that the ground-based base stations are no longer in operation, and that means that typically rescue workers do not have communication capabilities. So what we have been doing with this company is to work on a flying base station, a drone that then optimally positions itself over the disaster area so that I have maximum connectivity for the rescue workers below it, and I have sufficient or maximum backhaul, because the base station, of course, has to talk to other base stations that are further away in order to get the signals out to the system. And we started this work with one base station and using reinforcement learning to optimally position the base station in the place where it should be. And then we moved towards a federated reinforcement learning approach where you have multiple base stations that together are autonomously positioning themselves optimally within the disaster area so that together they reach a global optimum for both backhaul and communication for rescue workers at the bottom. And again, there's a paper reference in the bottom in case you're interested. Conclusion. So what I wanted to share is, first, I hope I managed to convince you that in my view, or based on our research, we believe that companies are wasting or could be much more effective with at least half of their R&D budgets. I mean, 7 to 9 people of every 10 work on commodity functionality. New functionality is built but is only useful in half or less of the times. Second, many companies, and I'd love to hear from you what the situation is within your company, are not clear on what is it that delivers value to our customers. I mean, if I go to one of our companies, for instance, that builds vehicles, and we ask them, what is the value of the vehicle? You get many different answers, but the company falls into the worthwhile many versus the vital few trap. They have so many things that they consider to be valuable that they fail to focus on a critical, vital few that you can actually use for steering R&D and prioritizing efforts. And then finally, I believe, and I hope I've convinced you of that we really need to use experimentation as a mechanism to avoid building things that don't get used and to find ways of optimizing functionality that is used by customers, but making sure that it is created in such a way that it is optimal from a user perspective. And with that, I wanted to mention that I have a very unhealthy habit that I sometimes write shorter and longer books. The Speed, Data, and Ecosystems book, where I describe some of the earlier work, is for sale on Amazon.com. But the other 6 books that you see here, I give away for free in PDF format. These are typically shorter books, between 50 and 100 pages. Of course, there's books on data. There's books on the 3-layer product model. That's impactful software. There is some more on a higher level around digital transformation. There's a short book on software platforms, as well as on what I've identified as the top 10 fallacies in product development. So if you're interested, drop me an email at jan@janbosch.com, and I happily send the links to those books to you. And with that, I would like to thank you for your attention. You can find me on janbosch.com, LinkedIn, Twitter, and I publish a weekly blog post every Sunday morning at 8 o'clock Central European time. And if you're interested in that, feel free to take a look at that. But with that, I would like to give the floor back to Jan and ask him if any questions have come in the last 40 minutes or so. Thank you.
Well, Jan, this is Will, who's able to join you after a somewhat of a confusing circumstance, which we will not go into at this moment. But I must say, you have not disappointed my expectations. I had looked forward to introducing you and wanting to alert the attendees that you have a very impressive track record, and that if you thought this webinar/talk was good, you should just try YouTube, and you have a plethora of high impact and high energy talks that I consider to be very impressive. So with that, I will move on to thank you once again for your excellent presentation, and move on to the list of questions that have been coming in. First, let's just say you identified 3 areas: the automated experimentation, federated learning, and reinforcement learning. Of those 3 areas, which do you think will have the most significant impact in the future for product development?
So if we look at how many companies build products today, what we see is that everyone wants to specify the functionality in the product, build that functionality, test the heck out of it, and then deploy it. They don't want surprises in the field. And even in a DevOps cycle, that's how people typically work. I believe that in the future, we will move to products where some part of the functionality is actually organized in such a way that the system autonomously and by itself will experiment with the best way of delivering certain functionality or certain features. And let me give you a quick example. I have adaptive cruise control in my Audi A4, which is built by a large tier 1 provider in Germany that I will not mention, but I'm not very happy with the adaptive cruise control system. So what I would want is a situation where the adaptive cruise control system would learn how I would want it to behave, and then would start to behave more and more according to my wishes. And that requires forms of reinforcement learning to be added to systems out in the market. And I believe that that's going to be one of the big areas where at least I'm now starting to look into on how does one actually select that area? How do you structure a problem in such a way that you avoid, so that you can explore the whole state space or behavioral space? How do you avoid the worst case negative consequences, et cetera, et cetera? So I believe that that's an area that is quite interesting, Will, and that I would love to understand better. And I believe many companies would benefit from looking into that.
Well, I wish you luck in going down that train of thought, which I would like to circle back around to the underpinning question of software architecture. What are the implications of these 3 approaches, well, AI in particular, or some of the other areas that you have covered in, how would you say, changing the mindset or some of the fundamental assumptions that go with either components-based design or software architecture?
Yeah.
Please.
Yeah, and Will, this is a really good question, and I don't know who in this call has been deeply involved in the software architecture community, but I wrote a book in the 90s on software architecture where I was basically following at that point the primary way of thinking about architecture, which is you have to be really careful about how you design your architecture. You have to do careful evaluations and assessments of the architecture, but because once you commit to the architecture, you're stuck with it, and it will be very, very difficult to change. That's how we at that point believed that architectures worked. And then with the adoption of Agile, of course, we realized that we can evolve architectures, and we are continuously evolving architectures. And to be honest, one of my claims is that no product or platform will ever have to be retired as long as there is a customer interested in it, as long as you invest enough in architecture refactoring. So I believe that that's an important starting point for your question, that architectures are not poured in concrete. They can actually evolve. It's just typically much more expensive to evolve an architecture than just to evolve some feature in the system. When we look into, sorry, go ahead.
No, I was just going to say, has the impact of AI further turned some of the assumptions that we make in creating an architecture as far as reusability or in return on investment, let's put it that way.
Yeah.
And that suddenly it's a new ballgame.
I believe that, yeah, so we tend to talk about binary changes. I believe that this will be a more gradual change, but I believe that we will see even more dynamism in the way that architectures get designed and used. And one of the big drivers here is that architecture tends to be primarily used to help humans understand how the system is structured. But once we move to a situation where significant parts of the system are generated by machine learning models or are realized using reinforcement learning algorithms, the need for humans to deeply understand all the ins and outs of parts of the system will go away. And that will allow machine learning, I believe, to generate architectures that are not optimized for human understanding, but are optimized for other types of KPIs like performance or integration between different parts to optimize behavior, etc. So I believe that that's an area in software architecture that I've only recently started to look into a little bit. I don't have more to share, but I think that there will be quite significant implications for software architecture as well, Will.
Well, thank you. Thank you. I appreciate those insights, but I would like to follow that question up with sharing with the listeners who else might be turning over these stones, so to speak, and are there any publications that you might direct them to or suggested Google searches that would provide additional insight into who else is doing what?
Yeah, so one of the things that I've been actively involved in, and I would recommend people look at if they're interested in this, is the conference series on AI engineering. It's called CAIN, C-A-I-N, and we've been co-located with ICSI for the last 3 or 4 years, I think. First, it was a workshop, and then it became a conference. And I would really recommend people to look at the conference on AI engineering to find much more work and publications in this area.
Well, that is good advice. And well, let's just say that I've left several areas which are sort of more deep dives into some of the topics that you covered today open, and I would encourage you, for your own interest, and if you have time, to maybe wrap those up into something that you'll talk about in the future, or just send us those answers as they come about and you've evaluated the most return on your investment. So with that, I think we're going to have to wrap things up for today. And once again, I thank you, Jan, for his phenomenal, highly inspirational and innovative thoughts on the topics. And We also thank you, the listeners, for tuning in here. If you have any questions, we encourage you to continue to follow up. And with that, I am going to say thank you for your time and turn it back over to Jan for any other comments that we have at the end of this webinar.
And once again, thank you for inviting me. Thanks a lot. I
Yep.
appreciate it.
Thank you.
Okay, so with that, thanks a lot again, Jan, and thanks to Will. And we thank everybody who attended today, and we hope to see you again in the future. Thanks.